Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. A chiral compound is one that is non-superimposable on its mirror image, meaning it lacks an internal plane of symmetry or any improper rotation axis. A molecule is achiral if it possesses a plane of symmetry, center of symmetry, or other symmetry element that makes it superimposable on its mirror image. Moving on to the next step. Compound A is a norbornene-type bicyclic system bearing an exocyclic double bond is equal to CH-CH3, i.e. AZE alkene with CH3 and H at C7 and two acetyl groups at two different ring carbons. The presence of the exocyclic double bond with CH3 and H creates geometric asymmetry, and combined with the rigid bicyclic framework and two substituents, two acetyl groups, at distinct stereocenters on the ring, compound A has multiple stereocenters with no internal plane of symmetry. This makes compound A chiral. Moving on to the next step. Compound B is a norbornene framework with Me and H at the C7 bridge carbon and two NH2 groups on adjacent carbons. Although there are stereocenters, the two NH2 groups on adjacent carbons in a symmetric arrangement can create a meso-like situation, or the molecule may have a plane of symmetry through the framework, rendering it a chiral, meso compound. And for the final step, compound C appears to be cubane or a highly symmetric cage hydrocarbon. Cubane, or similar structures, possesses multiple planes of symmetry and high molecular symmetry of point group for cubane, making it a chiral. Compound D appears to be a bicyclo, 2.2.0, or similar symmetric structure. The drawing shows a symmetric polycyclic hydrocarbon with a plane of symmetry, making it a chiral. Among all four compounds, only compound A lacks all symmetry elements that would make it superimposable on its mirror image. The combination of the rigid bicyclic skeleton, the exocyclic double bond bearing CH3 and H, restricting rotation, and the two acetyl-bearing stereocenters in a non-symmetric arrangement ensures chirality. Compounds B, C, and D all possess symmetry elements, planes of symmetry or meso arrangements that render them a chiral. Therefore, the correct answer is A. Therefore, the correct answer is option A.